Hey guys, today I'm at the school. So uh, today lecture is we still learning about the basic concept of electromagnetism, right? So today lecture two is subject is electrical energy, electric force, electric charge, electrification. I know this word kind of looks like similar, but makes us kind of headache. But I will try to explain simply what I mean. But we need to know, we have to know about this concept. Okay, let's see. First of all, what is work? Work is we did something, right? For example, I grabbed a phone and move. This is work, right? From here, a point to here, right? So we say this is mechanical working. We need to learn. I mean, we should try to understand the concept widely. Okay. So, for example, work is done when force moves through a distance. Here is A point. Here is B point, right? And I'm standing here. I'm trying to move this stop like this. This is work. So we say this is mechanical working. Got it, right? And next is what is the electrical working? There's two pictures, right? First part is connecting electricity supply wiring to electrical equipment or disconnecting, which means actual working. What I'm saying is electrical working is like bulb. You know what I mean? It's light. you know electrical equipment is working, like TV is on, cell phones on, like we say like this is electrical working, right? Next step. So yeah, there's Coulomb's law, right? But we should understand why is it important to Coulomb's law. You know what I mean? So here's the equation, but now I will explain it without it first. Okay, there's a plus and minus charge, right? This Q1 and Q2 means charge. You guys always confuse what is the electrons and the charges. I'll explain soon later, okay? But since we are electrician, you know what I mean? So we just need to see widely about this. I mean, if we have a time where we are more interested, we could study. But what I mean is just this part is what I suggest is just trying to understand widely what is concept, okay? So let's see. Coulomb's law, there's positive and negative charges, right? So for example, here's plus plus, right? As you know, we have a magnet, right? The concept plus plus. There's something power between them. But if plus plus, we cannot attach. You know what I mean? There's a repair power. You know what I mean? Cannot. But instead, minus plus, it's attached. You know what I mean? This is basic concept. Let's see more. So we now know between charges, there's something energy or power thing, yeah, we could say, right? So for example, between plus plus, there's repulsive power. And instead of minus plus, there's attractive. So we could say this is electric force. So with this electric force, our electric stop working, like a phone or TV. So based on electric force, it works. And now I could finish this concept, but we need to learn more about it. So Let's go more, okay? I'm sorry about to show you guys kind of looks, yeah, makes us headache equation. But it's important thing, yeah. First of all, here, the upper side, numerator, charge, right? And here's denominator, here's R. R means here's distance, okay? And K is a constant number, just equal to now, okay? So which means, but you guys need to learn about this concept. If it's, if there's equation, this upper side, numerator part, proportionally, you know what I mean? Just proportional effect. But instead, denominator, this under part, we say, inversely proportional. Just a reverse mean, you know what I mean? So for example, here's the power. The power itself is proportional to charges, but inversely proportional to distance. Okay, try to understand this concept. Let's go more. Okay. Okay. So today's, the most important concept is electrification. So electrically, neutral atom become a charge with an electrical meaning by external energy. Just simply thinking, here's a Bose model. I'll explain more deeply, okay? But the concept is there's a, okay, let's move. Give us a sec. Okay. So, here's Bose model. I will, yeah, draw one more time to understand you guys. So look at that. Here's Bose model, atom, and here's electron minus, electrons has a minus. And, oh, look at that, this concept. Nucleus include protons and neutrons here. The same is, so we could say here. Proton and neutron. Neutron is just nothing. Awful. So let's talk about it. First of all, at first time, initially, it's electrically neutral, this atom. But because of external power, like heat or wind, or physical power, I will explain more, okay? Because of something external power, it affects and it makes it electrically, having a energy. What I mean is now it doesn't have an electrical meaning, I mean power or energy, but because of external energy, it makes it electrically, having energy. For example, look at that. Here's the sun, right? Sun. And the sun affects this, atoms. Oh, you guys need to learn about it, nucleus. Nucleus part is kind of heavy, compared to these electrons. So generally, this part don't move. You know what I mean? Just a moving part is these electrons. Okay. So if it's affect, so it comes out. You know what I mean? So now we say this is coming out is a free electron. Oh, you can see here's location, right? Nucleus, orbit. Orbit, outside of layer, you know what I mean? And nucleus is here inside. Good. So because of the sun energy or something, yeah, now the electrons, it comes out. and we say this is 3 electrons. And now it has energy minus energy. We say now it become charge, negative charge, we could say. Okay, but what about this? It has plus protons for it has, right? But the minus electrons now 3, right? So this atom gotta be plus, because look at that, 4 minus 3 is 1, right? So it gotta be, yeah, plus charge. So we make it now minus negative charge and plus charge. So now it has energy, minus energy and plus energy. We say this is electrification. You know, it's a basic of the concept how we get it the charge. You know what I mean? I said that there's two ways of getting the electricity. One is trying to rotating. You guys remember rotating the coil, magnetic field change, and the one is getting the charge. Charging part is this part. Okay. Yeah, I guess I hope you guys understand this part. And let's see more. Okay. So, okay. So let's see. Yeah. Still, we this is conclusion. Okay. Protons have a positive charge. Neutrons do not have a charge. And electrons have a negative charge. But because of the something external energy, it makes it to become a charge. Protons gotta be positive charge, and electrons gotta be a negative charge. So now when they become a charge, they have electrical energy they having. Okay. Yeah. And yeah, we almost done. Don't worry about it. So for example, electrifications, for example, I will say, okay. So here's, for example, it's a static electricity. For example, now, my clothes and my body, they both of them are electrically neutral. But now I want to take off this, right? If I want to take off, there's external power, right? Like friction, right? Between my body and my clothes, right? So when I get the power to here, it effect. So one of them, it gotta be negative charge, and one of them gotta be, if this is, for example, to try you guys to understand, more easily. So for example, my body is gonna be a negative charge, and this clothes it's gonna be a plus charge. So when I take off, when I try to take off this clothes, it's not easy. That's it. So there's something power thing. Yeah. So we say it has electrical power. And another example is this balloon and our hair. You guys already know this concept, right? It's just same thing. Yeah. Between them, there's actually nothing, electrical power. But when he try the balloons to like this, and our hair is gonna be coming up, right? Balloon. Then we say this is electrification example. Yeah, today's lecture is done. Thank you.